All right, we're on 1.3, which is collinearity, betweenness, and assumptions. All right, so let's start with collinearity. Points that lie on the same line are called collinear. So, for example, points A, B, and C, there is a line drawn through them, so you know that they're on the same line. Without that there, it doesn't matter what it looks like. If the line's not in the diagram, you cannot assume that they are collinear. There is a line drawn, so these points are all collinear. Points that do not lie on the same line are called non-collinear. So points E, D, and F, those are non-collinear points, very obviously. But if I drew points that were, say, like this, and I said D, E, and F, those would also be non-collinear because there is no line drawn with them. So keep that in mind. Even if it looks like a line, if there's not a line drawn, they're non-collinear. Okay, so in the diagram below, R, S, and T are collinear points because there's a line drawn and those points are all on the same line. P, O, and X are also collinear. You could also say that Y is collinear with those as well. So P, O, X, and Y are all collinear. However, M, O, X, and Y are non-collinear because when you look at all those points together, M and O are collinear themselves, and O, X, and Y are collinear themselves, but the four of them together do not lie on a line. Alright, so now we get to betweenness of points. Now for a point to be between two other points, all three of the points have to be collinear. So again, they have to be on the same line, and one of the points has to be between the other two for it to be between those points. Okay? With X, O, and Y, for example, O you cannot assume is between X and Y because those are non-collinear points. Here T is between A and R, O is not between X and Y. Which kind of brings us to the next point, which is triangle inequality. So this is very important, okay? For any 3 points, that means you're given 3 points. There's only 2 possibilities. One is that they are collinear. Okay, 1 point is between the other 2, and 2 of the distances add up to the third. So B is between A and C here, and if AB is 5.5 and BC is 12.5, AC would be 18, because when you add those together, and these are all line segments, by the way, I should be using proper notation here. So when you add those together, you get 18. Okay, so that's if they're collinear. However, if they're non-collinear, the 3 points determine or form a triangle. So if I have these 3 points here, okay, no line drawn connecting them. Okay, so we can connect 2 at a time and they will form a triangle if there's only 3 points. Okay, now with this is important to know. If you add any 2 sides of the triangle, it must add up to be more than the other side. Otherwise, it is not a triangle. For example, if I take 11 plus 14, I get 25, which is greater than 24. If I add 11 and 24, it is greater than 14. And if I add 24 and 14, it is greater than 11. So this is going to be important. The sum of the lengths of any 2 sides of a triangle is always greater than the length of the third. Keep that in mind. Alright, now, assumptions from diagrams. It's important to know what you can and cannot assume from looking at a diagram. So I've got a chart here. I know I said to paraphrase, but you are definitely going to want to copy this chart down. So now would be a good time to pause and copy this. These are things you can and should assume. Straight lines and angles. So if you have 3 points that are connected, you can't assume that it's an angle. You can't assume the type of the angle, but you can assume it's an angle. You can assume collinearity of points. If you have 3 points on a line, you can assume that they're collinear. If you have collinear points, you can assume that one of the points is between the other two. And you can kind of get the relative position of points. Okay, things you can't assume right angles, even if you had an angle that looks like that, and I said, what type of angle is that? You should not say right angle. Okay, you can assume, or you cannot assume, I should say, congruent segments. If I drew a triangle, that's a bad one, but let's say that I said, are any of these sides, so for example, if this is triangle ABC, without any kind of markings on that triangle, you cannot assume that AB and BC are congruent or have the same measure. You also can't assume congruent angles. Even if they look like they're mirror images of each other, you can't assume that. And then relative size and segments. For example, I could draw a triangle. I always like using triangles as examples. Okay, so I could draw a triangle here, and I could say that this segment's 30, and that segment's 2. And you would have to go off of that information, even though the triangle obviously doesn't look like those are the measurements. Okay, so be very careful of that. Be wary about assuming things from diagrams. So for example, and here's again, this is an example, so make sure you're getting this down. Given the diagram you're shown, the question is, what can we assume? So I want you to pause it and write down 4 things that you can assume and 4 things that you cannot assume. So pause it, write those down, and then come back and see if one of your 4 things, or if your 4 things are on. So things we can assume. We can assume that line ACD and line BCE are straight lines. And the only reason, you are almost never going to do this, and that's using 3 letters to write the line. Typically, you only need to use 2. Okay, the only reason why I included C is because of the betweenness that we covered in this section. Okay, but typically you're only going to use 2 points to note a line. You can assume that angle BCE is a straight angle or a line. Because if you have a straight line like that, you can assume that it's a straight angle. Remember that straight angles and straight lines, those are basically the same thing, but it can be an angle or it could be considered a line. It's just a straight angle. You could assume that C, D, and E are non-collinear because of relative position. There's not a line drawn through all 3 points. There's a line drawn through D and E, and there's a line drawn through C and D, but not all 3 together. You could determine that C is between B and E because they lay on the same line. They are collinear. And you could assume that E is to the right of A. Because of how the diagram is, the most you could assume is that E is to the right of it. You could assume that C is to the left of D. But other than that, you can't determine distance or anything like that. Things you cannot assume, that angle BAC is a right angle. You cannot assume that that segment CD is congruent to segment DE. You can't assume that angle B is congruent to angle E. You can't assume that segment BC is longer than segment CE. And you can't assume that angle CDE is an obtuse angle, or BCD. You can't assume, even though that's clearly looks like an obtuse angle. And if you got a protractor out and measured it, it would be obtuse. But without being given that information, you cannot assume it. Alright, and that's it. Nice short video for the evening or day, whenever you're watching this. Come prepared. You may have a short quiz tomorrow based on what you've learned so far.